Okay. Well, let's go ahead and get started. We will definitely wrap up chi-squared this week. It's probably going to go ahead and take us, through tomorrow, probably a little bit of time on Friday, but we should pretty much get it wrapped up by the end of the week. We'll probably have some additional problems at the beginning of next week to go ahead and talk about, just to kind of reinforce it, make sure you feel comfortable with it. We have our last focus activity of the 6 weeks right here. In fact, if you're not going to do it at the end of class today, tomorrow is when they're due. You're going to be turning in numbers 4 through 7. Okay, this guy right here. Now, I didn't mention anything about Thursday yet, especially when it comes to chi-squared, because what's happening on that day? That's when you have your test. Okay, the second exam's coming up in a couple of days. It'll have cumulative frequency on there, standard deviation, normal distribution. I went ahead and made that into our last focus activity because some of the grades on that previous quiz were a little low. It's also going to have correlation on there, what we were just looking at, linear regression. You might be asked to go ahead and find a prediction equation, possibly even predict the outcome based on a certain value. Okay, so that's coming up on Thursday. Now, Friday morning is going to be the deadline if you want to retake the normal distribution quiz. Just don't forget, you can't retake until you have the homework done. So if you're having trouble, come on in, let me help you out. Okay, 7:45 in the morning, my door will open. Just kind of be thinking about these last few grades because next Friday is what? It is the end of the first 6 weeks. We'll already be a third of the way through the school year, well, the first semester, I should say. And then the second 6 weeks is going to go even faster because that's only a 5-week 6 weeks. So it's going to go pretty quick. All right. So let's go ahead and take a look at what we got here. It says, when a specific variety of radish is grown without fertilizer, the weights of the radishes produced are normally distributed with a mean of 40 grams and a standard deviation of 10 grams. Now, when the same variety of radish is grown in the same way but with fertilizer added, the weights of the radishes produced are also normally distributed, but this time the mean is 140 grams and the standard deviation is 40 grams. Okay, so you want to be very careful about the values you're going to use. Determine the proportion of radishes grown without fertilizer with weights less than 50 grams. Let's go ahead and do this first one together, then I'll go ahead and give you a few moments to see if you can get the rest of them on your own. All right, so without fertilizer, which means I want these values right here. Okay, so I want it to be less than 50. Now remember, all of this is done on the calculator, so where do I go? Well, we're on the calculator. Okay, step 1 is done. Then we want to go to menu. Okay, so once we're on our calculate screen, okay, menu, statistics, distributions, yes. Normal PDF or CDF? CDF. Okay, now the first question says without fertilizer with weights less than 50. Does that make 50 a lower or an upper? Upper. So this lower bound I'm going to leave as is. I'm going to put the 50 in. Then I need the mean without fertilizer. So that would be 40 with a standard deviation of 10. Okay, so as soon as I click OK, looks like I have about 84.1%. Okay. Jaylee, you okay? Okay. So about 84.1%. Okay. Now, take a few moments, try to figure out the rest of those. Okay. So it looks like we have 3 additional problems with fertilizer and 2 more without. You just want to make sure you're using the correct values. And in just a moment, I'll just go around the classroom, ask folks what they got for particular answers. And if we all agree, great. If not, I can put it in the calculator. Definitely check out what we have there. if you're still having a little bit of issues with normal distribution, you can check with your villain buddy, those around you who are the same villain. If you're getting the same answers, fantastic. If not, we can talk about where we're going wrong. You may not be completely done. That's okay. But I'm going to go ahead and move on. B, with fertilizer with weights less than 60 grams. Okay, so by show of hands, who believes they have this one? Okay, Radley, what'd you get? 2.28% is what I got. 2.28%. Now, if there's any of these you want to take a look at, please let me know. Okay. How about C1? Jacob, you got that one? What'd you get?
I got 2.1, but I rounded it.
Okay, 2.1. Okay. I went ahead and said 2.14, but perfect. That's exactly right. Okay. Did anybody get C2 without fertilizer between 20 and 60 grams? Okay, Jan, what'd you get? Okay, 95.4. Would you guys agree? I got 95.5. Okay, but that's fine. I mean, if this were like a test that I would happen to be grading on Tuesday and I've got 0.5, but he's got 0.4, would I count off?
Yes.
Oh, yeah. You guys knew where I was going. I would not count off. You've ruined my joke. Grr. Okay. I'm a little grr. DI, with fertilizer greater than 60. Who believes they have this one? Okay, Joe, what'd you get? 97.7 is what I got. And I got one left. D2, who believes they have the final answer here? So I only see a few hands going up. Bradley, help me out again. I got 2.28. Okay. Jaylee, so I'm going to guess that at least one of these answers you did not get?
I'll try to go down and it erases all the nines that I put.
Oh. Yeah.
And I'll try to go down.
Okay. And it's like what? Jinkies. Okay. All right. Well, is there any of these you would like me to put in the calculator? Okay. All right. So besides Jaylee, how's everybody doing? Everybody's good. Okay. All right. Do we feel a little better about normal distribution now?
Yeah. A little better.
A little better. Good, good, good. Again, really when it comes down to it, I think big picture, it is important for you to be able to do some of these problems by hand, which is why I have you do those. But ultimately, it comes down to the technology. If you can perform these concepts on the calculator, you are going to be golden for those paper exams. Okay. So if we have time today, we'll go ahead and turn them in. Not right now. Okay. The stapler is going to be on my desk. If not, tomorrow I'll have up on the front board here, please turn in your focus activities as a reminder. I'll say something. So that should be a guaranteed grade tomorrow. Let's see how far we can get with the little time we have. I think this will probably be just a little more than a quick review, like a refresher, because it's been a 3-day weekend. And then tomorrow we'll probably really get back into it. Okay, so we've been talking about our last statistical strategy here, the chi-squared test for independence. Okay, so we call this kind of table here a contingency table, or it's a 2x2 table because we have 2 columns and 2 rows of information. So this is what we refer to as the observed data. Okay, the notation we use here is F naught, F sub 0, okay, or F sub O, depending on how you want to look at it. Okay, now one of the first things we talked about last week when I introduced chi-squared was using the observed data, we went ahead and found what the expected data was. Okay, that's F sub E. All right, well, how do we find the expected data given the observed? How do we do that? Okay, and let me go ahead and move to this table right here. There you go. Now in the table, each column has a sum, each row has a sum. So in the bottom right, that's the total number of elements, participants, whatever it is that you happen to be collecting data on. Okay, so if I want to go ahead and find an expected value for any of these, like if I wanted to go ahead and find the expected value for females who regularly exercise, I would take the total of that column, the total of that row, multiply them together, and then divide by the total number of participants in the study. Okay, because 208 and 184, that's the intersection of the cell that I'm looking at, females who study or regularly exercise. Okay, but now what does it mean expected values? What is that actually telling us? Okay, so I see what you're saying. So here we're talking about gender and exercise, right? So if there was absolutely no relationship between gender and exercising regularly or not, these are the values we would expect to get. Okay. Everybody okay with the expected values? Okay. Then we did several of these by hand, and the one thing we kept seeing was that if you go ahead and calculate a very small chi-squared value, okay, what'd that tell me about my quantities? They're independent. Okay, so that means there's no relationship. Okay, there's no association between the quantities that you're comparing here. Now, on the other hand, if we did calculate a larger chi-squared value, that would tell me that they are not independent, which means there is some kind of relationship, there is some kind of association. But remember, the chi-squared test for independence is basically a yes or no strategy. It won't tell you what the relationship exactly is. That'll be for you to go ahead and determine based on your analysis or what you believe your opinion is. Okay. So we did our first one here where we got a very small one, so we said independent. Then we practiced some expected values, found another one where we found 6, so we said they were not independent. Now, the question we kept bringing up last week was, okay, at what point does the value become so large that we're going to go from saying these quantities are independent to saying they are not independent, that there's a relationship between the two? Does anybody remember the 2 factors that I'm going to use to help me determine that? One starts with an S. Was it? It's a certain level. Significance level, that's a percentage. And the other one was a little phrase, starts with a D. Degrees of freedom. Those were the 2 items that were going to help me determine, well, exactly how big the chi-squared value has to be before it becomes, I would say, not independent. There's an association between the 2. Okay, so degrees of freedom, when you're looking at these contingency tables, it's a very simple formula. You take the number of rows minus 1 times the number of columns minus 1. Remember, what rows and columns do you not include? You don't worry about the summation. You only look at the data itself. Okay, so for a 2x2 contingency table, the degree of freedom, what they call DF, is just 1. All right. Well, what does it actually mean, degree of freedom?
Since you just have a 2x2 table, select one number that determines what the other is.
There you go. For the 4 cells we have here, any of the 4 can be any number that I want it to be within the sum totals. But as soon as I go ahead and choose one cell, the others are automatically going to be chosen. I no longer have a choice on that. They are predetermined. Okay. Same thing, I believe we were looking at a 3x3. Okay. Where the degree of freedom was going to be 4. So for a contingency table this large, I could potentially fill in 4 of those cells with any numbers I want. But as soon as I go ahead and plug in that 4th cell, the rest of them are already predetermined, okay, based on those choices. Okay, so that's degrees of freedom. And then what does it mean significance level? What were the 3 we were talking about? 10, 5, and 1%. Okay, so 10%, 5%, 1%. Okay, what's the difference? So, like, is there a difference between, say, 10% and 1%? So what is that? There you go. If you're wanting to be more accurate, you're going to go 1%. Okay. If you're wanting to give yourself a little more leeway, maybe not have it as exact, probably choose 10%. Personally, I always go 5%. I like to call it the middle of the road. Okay. Because it's not too strict, but it's just strict enough. Okay. And is it possible to, let's say if I were to test some quantities, like maybe the one we were just looking at where gender was facing off against exercise regularly or not. Let's say those two quantities, if I go ahead and test it at 5%, if my test shows that there is some kind of relationship, is it very possible for me to test it again at 10% and show that there is no relationship? Yes. So that could be something to keep in mind when you're looking at your internal assessment. This is typically one of the bigger math strategies. This is a further math strategy as well if you're looking at your rubric. That's going to get you the additional points on, I believe it is criterion C, the math processes. Okay, because you have to have two simple and one further, and this is definitely considered a further process. All right, but to get those extra points, just you'd be looking at that rubric. Okay, so that's basically what we've been talking about since last week. Does anybody have any questions over that? Okay. All right. So the next step is going to be to go ahead and talk about one detail. Now, this is where I'll go ahead and end it today, and this is actually the next lesson we're going to talk about next week, but there are limitations to the chi-squared test. Okay, one of them being, if you go ahead and calculate the expected values, it's this guy right here, okay? If you calculate your expected frequency values and any of your cells are less than 5, the value of 5, that potentially could be a problem for your analysis, okay? But there is a little loophole here that's very useful to you. If 20%, okay, of the expected frequency values are, okay, less than 5, okay, your analysis is still going to be okay. If 20% or less of the numbers, the cells in your expected frequency values are 20% or less, your analysis should still be okay. Now, if it's 20%, well, I should say above 20%, since I already said 20% or below. Above 20%, no. Okay, you're going to want to do something, and there are some methods for dealing with that. One could be combining rows and or columns to change the data. It's probably an issue with the way you're collecting it, but that's something we're going to talk about next week. I just kind of wanted to point this out. John Henry?
Like why? If they're less than 5, like why is that an issue? How does it affect your...
That is something we'll talk about next week with the limitations. I just kind of wanted to point it out since it was right here. Okay. So pretty much tomorrow, since we did our review today, I'll talk about what's known as the p-value, and then we'll go ahead and get right into our last major example, and we'll just work a few tomorrow and see what you think. Okay. Questions? Now, will this be on the test Thursday? No, this is not on the test. Not on the test. In fact, I'm going to go ahead and give you the homework assignment tomorrow.